In this tutorial, we will be discussing how to name ionic compounds with transition metals. Molecular compounds are compounds that are formed by two or more nonmetals. The basic unit of a molecular compound are molecules, and they're composed of the constituent atoms. Ionic compounds contain one or more cations paired with one or more anions. Cations are positively charged ions because they've lost electrons, whereas anions are negatively charged ions because they've gained electrons. If you have problems deciphering between the two or remembering that, look at the first part of the word cation. Cat. Think of this as a mnemonic device. Cats have paws. Cations are positive. That might help you remember that in the future. The basic units that compose dry ice, a molecular compound, are carbon and oxygen carbon dioxide molecules. We see that here. Notice their individual molecules. Whereas the basic units that compose salt, an ionic compound, are NaCl formula units. Notice there's no distinct beginning and end. It keeps going on and on and on. When a metal which has a tendency to lose electrons, therefore becoming cations, which are positive, combines with a nonmetal which has a tendency to gain electrons, which means those are anions, and they are negative, one or more electrons transfer from the metal to the nonmetal, creating a positive and negative ion that are attracted to each other. A compound composed of a metal and a nonmetal is considered ionic. The basic unit of an ionic compound is the formula unit. Unlike molecular compounds, ionic compounds do not contain individual molecules, but rather cations and anions in an alternating three-dimensional array. We saw that in that previous picture. The ions kept going on and on and on rather than having distinct beginnings and ends. Chemists have developed systematic ways to name compounds. If you learn the naming rules, you can examine the compound's formula and determine its name, and vice versa. Many compounds also have common names. For instance, H2O has a common name of water. However, the systematic name is dihydrogen monoxide. Since water is such a familiar compound, everyone uses its common name and not the systematic name. Common names can be learned only through familiarity. There is no system. In other words, you need to memorize it. So let's take a look on how to name ionic compounds. The first step in naming an ionic compound is identifying that you have one. Remember, anytime you have a metal and a nonmetal together, chances are you have an ionic compound. That means you'll have one from this side of the periodic table and one from this side. Notice this squiggly line that separates the metals and the nonmetals. Ionic compounds can then further be categorized into two types, depending on the metal that's in the compound. If the metal can only form one charge, that's a representative element, and they don't need any special considerations, whereas ones that form multiple charges, in other words, it can have a +2 at one point and then a +3 on another. That takes a little bit more effort. We're going to focus on the second part. The second type of ionic compound, or type 2, contains a metal with a charge that can differ in different compounds. Such metals are usually, but not always, found in the transition metal section of the periodic table. Some transition metals, such as zinc, which always has a +2, and silver, which always has a +1, form cations with the same charge in all their compounds. Similarly, in some main group elements, such as lead and tin, form more than one type of cation. Usually they'll form a +2 and or in other times they do a +4. So here are some of the list of transition metals that have multiple charges. Sometimes they have a common name to coincide with the Roman numeral. For instance, Cr2 plus versus Cr3 plus, chromium 2 versus chromium 3. Chromium 2 is chromous, while chromium 3 is chromic. Iron 2 versus iron 3. Iron 2 is ferrous, while iron 3 is ferric. It might help to know the difference between these two. Binary compounds are those that contain only two different elements. The names of the binary ionic compounds contain the metal that forms only one type of an ion that is formed. So it would be just the metal and the nonmetal. Since the charge of the metal is always the same for these, it need not to be specified in the compound's name. For instance, sodium chloride, NaCl, sodium will always be a +1 and chlorine will always be a -1. So we don't have to say sodium 1 chloride. So notice there's no parentheses there. The base names for various nonmetals and their most common charges in ionic compounds are listed here. So for instance, fluorine, if we look on the periodic table, fluorine is right here. Its rho is a -1, which is why fluorine, chlorine, and bromine and iodine all have a -1 charge. If it's coming off the periodic table, you're going to take the base of the word, which is typically the first syllable, and you're going to end it in "ide." So oxygen becomes oxide, sulfur becomes sulfide, fluorine becomes fluoride when it's in an ionic compound. So what happens if it does form more than one charge? Since the charge of a metal cation in these is not always the same, the charge must be specified by the metal's name. We specify the charge with a Roman numeral in parentheses following the name of that metal. So when you look at this 2 here is referencing the +2 charge. This 1 here is referencing that +1 charge. It's telling you the charge, not how many there is. That's one big mistake I see from students, is that they automatically think the Cu1 means that there's 1 copper. That's not what that's there for. The full name of these compounds are in the form of the name of the metal, the charge of the metal, and then the name of the anion. We can determine the charge of the metal from the chemical formula of the compound. Remember that the sum of the charges have to be 0. And so therefore the iron and the chlorine, for instance here, needs to balance out. If you've listened to previous tutorials, or if you've learned this in the past, you know that this 3 here came from the top. When we were given the name, we did the crisscross form. So that gave us Fe1Cl3. Remember doing the crisscross down. Well, to figure out the charge, we're going to reverse that and crisscross it up. So that means that 3 came from that iron 3. Notice here and here they're both a +3. Then you always double check the anion to make sure chlorine should be a -1. The name for the compound FeCl3 is the cation iron, followed by the charge, which is 3, followed by the base and ending with "ide." So iron 3 chloride. Some ionic compounds contain polyatomic ions, ions that are themselves composed of a group of atoms with an overall charge. Ionic compounds containing polyatomic ions are named using the name procedure we apply with the ionic compounds, except that we use the name of the polyatomic ion whenever it occurs. So that name doesn't change. So here, For instance, we have carbonate is CO3. If we see CO3, it's going to be carbonate. It's not going to change any kind of form of the word. Chlorate, if we see ClO3, it will be chlorate. It's not going to change the name. Many polyatomic ions are oxyanions, anions containing oxygen. When a series of oxyanions contain different numbers of oxygen atoms, they are named systematically according to the number of oxygen atoms in the ion. Unfortunately, it's not as cut and dry as 2 is this and 3 is that. It's more of a comparison. If there are 2 ions in the series, the one with more oxygen has an ending of 8. The one with fewer oxygen has an ending in 8. So NO3 versus NO2. 3 is more, so it ends in 8. SO4 versus SO3. 4 is more, so it ends in 8. Notice that the actual quantity didn't matter. It's a rating of them. If there are more than 2 ions in a series, then the prefixes hypo, meaning less than, and per, meaning more than, are used. So here is the original 2. So ClO2 is 8, O3 is 8 because it's more. If we go more than that to an O4, it's perchlorate. If we go less than that to only 1, it's hypo, for less than chlorite. So let's take a look at these. NiF2. So here's Ni. It's a transition metal, meaning that we need to figure out what the charge is. So to do that, we need to uncross it. So this 2 came from up here, and then this invisible 1 came from here. Always double check your anion. So fluorine is here. If we go through the charges, +1, +2, +3, skip, -3, -2, -1, 0. Fluorine is in a -1 row, so we're okay because it's -1 here. So it's going to be nickel, 2, in parentheses, fluoride. Let's do another one. Once again, nickel's in the transition metal. But instead of being nickel 2, when we uncross it, we find that it's nickel 3. Once again, double check the anion. Fluorine is supposed to be a -1, and it is, because there's an invisible 1 there. So it's nickel 3 fluoride. How about this one? Uncross it. That's +1 and -1. So we know we have iron, and we have oxygen, which then becomes oxide. If we look at iron, it's right here. It's in the transition metal, which means we need parentheses there. When we uncross it, we had oxygen being a -1. But if we look at the row, it should be a -2. That means when they put this compound together, they reduced it. We need to unreduce this by multiplying them both by 2. So iron 2 oxide, not iron 1 oxide. Let's do some more. Chromium is here. It's a transition metal, so we're going to put chromium. And then we're going to leave a space for the parentheses for the charge. And then we have sulfur, which becomes sulfide. We have parentheses there. That means we need to uncross it. 2- and 3+. Look at our periodic table. Sulfur is here. It's in a -2 row. It's -2 here. So that means we don't have to double check it, or we don't have to change it any. It's just simply going to be chromium 3 sulfide. So copper, looking at the periodic table, that's right here. It's a transition metal, so I know I need parentheses. ClO. So let's look at what our ClO means. ClO is right here. It's hypochlorite. Now we have to figure out what that means, what the parentheses are. Copper is a +2 here. According to this, hypochlorite should be a -1. If we go back to our polyatomic ion chart, it's supposed to be a -1. So we don't have to unreduce it, which means it's going to be copper 2 hypochlorite. And finally, lead. Lead was one of the two that is actually changes charges even though it's not a transition metal. So we're going to put parentheses there. C2H3O2. Let's figure out what that is. C2H3O2 is acetate, and it should have a -1 charge. So we put acetate here, and it should be a -1. If we look here, when we uncross it, it's an invisible 1 there, so we're fine. Lead should be a 4 because of this number right here. Now remember, if you have more than 2 capital letters, you know you have a polyatomic ion there, and that means you need to look at the chart. For instance, we have 1, 2, 3, 4 elements here. The one above it, we have 1, 2, 3 elements. We knew we had a polyatomic ion in that case, and so we had to figure out in our chart which one it was. Once you figure out what your polyatomic ion should be, then that's when you start to uncross and start to figure out the charge. Put parentheses around the polyatomic ion immediately, and that'll help you along the way. Okay, so in this video, we were looking at ionic compounds. We were looking at ones that form multiple ions for the cation, for the metal, which means we needed Roman numerals in there. If they are not transition metals, if they don't change charges, we don't have to use the parentheses.